So in this session, I'm going to talk about trends, patterns, and use cases in hybrid cloud API management. So my role for IBM as distinguished engineer for our integration portfolio covers things like our IBM API Connect offering, which is why we're here this week. You may have heard myself and some of my colleagues talking earlier in the week as well, but also a kind of broader integration space as well. So we have other products in the portfolio that I cover around app integration, high-speed file transfer, enterprise messaging, Kafka and event streaming, and all those sorts of things. So it's my pleasure to be here to be talking specifically about API Connect and the API space that we see in the industry today. Come on in, folks. No problem. Two mics now. Perfect. Okay, so what are we aiming to do for this session? So what I'd like to do is talk around kind of why hybrid cloud API scenarios are kind of hot in the industry today. Hopefully some of what we're discussing will resonate with you, kind of match things that you're thinking about in your industry or your company. Talk about some of the hybrid cloud API management patterns, and then I'm going to drill down into a couple of specific topics, one of which is about API portability, which is one of the key things that we are seeing with our particular customers as a kind of critical factor in how people are being successful in driving hybrid cloud API scenarios. So just to set the scene to start with, we kind of see across the industry, it's cutting in and out, this kind of great digital shift has been happening, particularly over the course of COVID and the global health pandemic. That acceleration in digital transformation for enterprises across a wide range of industries. So there's a statistic here from McKinsey, about kind of 10 years worth of digitization progress has been made in that 1 year from kind of 2019 to 2020. And obviously the pace that our business leaders are pushing us to adopt new technologies and to drive that digitization then drives further stronger requirements on us as IT and API providers in particular in this context. Because the API space is the critical enabler for those types of exchange scenarios. At the same time, significant kind of growth in complexity. So more and more applications being onboarded by different customers. Another example here from IDC, over half of organizations today say that they have more than 100 applications in their ecosystem. There's a US healthcare provider that I was working with 2 months or so back, actually through acquisition, like mergers and bringing in new partners. They actually say they have something like 400 new applications every year coming into their estate. And the kind of key challenge there is none of those systems can exist in a vacuum. They're all interrelated, or they need to be interrelated in some way. So we have lots of clients who are doing projects of things like know your customer. Can I have a single view of who my users are, who my consumers are, and use that to drive consistency and great user experience, and like a multi-channel user experience. Many of the retail sector, for example, have been on a journey over the last 10 years for how can I give you the same information, whether you're coming to me in store, via the mobile application, via the website, for example. One of our UK-based home DIY retailers I know fairly well. They started out from a position of having 3 separate companies for those 3 different channels. They had one company that did the kind of website piece, they had one company that did the store, and they had one company that did the mobile channel. So they had a real transformation journey to try and just bring those 3 channels together to give a consistent view for their end users and their customers. So kind of pushing into what does that mean in the context of hybrid cloud API management? And there are 5 scenarios that I'm going to talk through, a little bit of detail on each, and then we'll kind of talk about some of the technical topics as well. So kind of growing from left to right, as it were, very simple, straightforward starting point for many of our customers. First API project, often customers are starting from an on-premise data center perspective. So they have small, constrained kind of deployment footprint. They know where their APIs are going to be exposed from, very simple and easy to get up and running with. And that kind of starts very well. So that's your kind of initial footprint often. Some customers, that's on-premise. Some customers, if you're kind of starting and going straight to the cloud, then you're kind of deploying into some public cloud environment as well. But that's the kind of entry point, if you like. And then what typically happens is you end up in the kind of second phase that says, okay, so now I've done my first piece of API delivery. I've got some new projects. There's a new kind of digital transformation thing or a mobile application or whatever it is that's coming along. And that tends to then push to a model that says, okay, I have 2 different areas of API exposure delivering different types of API. So I know the order tracking API, for example, is in the kind of first, like the on-premise part perhaps, and the new like mobile web app sort of scenario is then delivered from kind of public cloud in many cases. And often companies are using those new channel engagement models also as a test case for how could we do things differently? How can we evolve our perhaps traditional IT estate, move that into a public cloud provider, get some of the benefits from that kind of reuse and dynamic nature of the public cloud. But you can see that you start to end up with a distributed model that says, well, I've got some APIs over here, some APIs over here, perhaps using different API providers depending on the particular environments that you're using, and starts to make things more complicated and more challenging from a kind of delivery and a maintenance perspective. So the third example we've got here is kind of getting into a hybrid deployment, and this is something that we see a lot of our customers very interested in. The gentleman from Gartner yesterday was talking about this in one of the keynote sessions as well, where you end up with a kind of federated or a distributed deployment model that says, well, perhaps I have a control plane for my API management provider. I want to manage that centrally, perhaps with a central API controlled team. And then I want to delegate kind of some level of responsibility to a line of business or a project team. Often that involves putting like the API gateway, the runtime invocation component, close to that business team's microservices, for example. So you end up with a model that says, well, there's a kind of split in my installation model, my deployment model, effectively. And those can be quite interesting as well. We have some customers that do that on a kind of local scope that says, well, even within my data center, I have a logical separation between where the API gateway lives and where the kind of control plane lives, how that's managed and administered. We also have some customers who do that on a kind of a distributed geographical basis. We have a managed SaaS service called API Connect Reserved Instance, has a control plane that exists in a public cloud provider managed by IBM. And the customer has the option to kind of take and deploy their own gateway in whichever environment kind of suits them. Might be their own on-premise data center, tethering back to this managed control plane. Could be another public cloud provider if they wanted to do that. But that flexibility and that choice of how you make that deployment is increasingly important as well. And then another interesting scenario, and this is one of the things that I'll kind of drill down into a little bit more, is around hybrid runtimes. So in this case, I perhaps want to expose the same sort of API but in different locations. And I'll talk about a kind of high availability and a resilience scenario around this a bit later, kind of push down into some more details there. But in this case, rather than it being different APIs that I'm deploying in each location, it's the same logical thing, and I want to replicate or federate that kind of further across to provide some either non-functional or functional advantages. And then lastly, and slightly different, once you're kind of in this kind of perspective of having lots of different deployments, different on-premise or public cloud providers, combinations of those, it then brings a kind of additional question, well, how do I manage these things? I've got this proliferation of different deployment styles. How do I provide centralized control and management so that I don't have to worry about the fact that they're all completely different? And this management angle is something that we see some customers kind of like building their own portal from an operations perspective, from an SRE perspective, for example. It's important to have consistency and reusability and repeatability, but also from the perspective of the provider of those APIs. How do I deliver those APIs in a consistent fashion? Okay, so I'm going to look at some technical considerations as well. So I have 6 of these in total. So I'll talk briefly about the first 4, and then I'll drill down into the other 2 as well as we kind of get towards the end of the session. So from a kind of technical delivery perspective, obviously there's lots of complexity and things to consider in whichever of those types of topologies that you might kind of deploy and make use of. So one of the key ones certainly is around, well, what is the flexibility of your deployment topology? And this is where many of the API providers, certainly IBM included, have different styles of patterns of deployment. Like, do I want everything in one place? Do I want that model where it's kind of federated with a remote gateway, for example? How do I join my different organizations together? Perhaps looking at multi-tenancy within the particular provider, so you can segregate lines of business and have different control and access permissions. Those types of things from a deployment perspective have both a kind of physical deployment aspect and also a kind of organizational impact in terms of how you segregate and divide up the various parts of your APIs. And then looking from an automation perspective, so the more complicated, the broader your API program becomes, the more important it becomes that you have standards and automation around that. And so previous speaker was talking about API standards, very good to see, lots of customers driving in that sort of direction. That there's also kind of CI/CD style considerations. So how do we automate that process of delivering APIs into a standard position? See a number of customers doing things different ways there. Interesting to see the contrast between a kind of early stage API project where people are kind of trying things out and learning for themselves, and the way that evolves into a more mature program, typically with more governance, often with kind of pattern-based deployments that says, well, I've got these 5 standard ways of delivering an API. I can expose perhaps a self-service portal to my application teams that says, tell us which ones of these you want to fit in, and we'll automatically generate the implementation template, for example. Security is always important, so particularly as you kind of grow across a broader spectrum of deployment locations, the question of where is your data going, where's the runtime path, where is that business data living, what sort of data do you have to kind of synchronize back and forth between the different locations that you're putting in place. So definitely an important area to be considering up front when you're looking at kind of deployments, particularly in a hybrid style. And then kind of lastly on the easy ones, as it were, operational simplicity. So people, our operations and SRE teams, certainly IBM included in terms of our managed SaaS offerings, it's important that the teams that we have running and maintaining these things on a day in, day out basis get that simplicity, the repeatability, the ease of monitoring and management and so forth, and the complexity and the breadth of hybrid cloud deployments drives that even more. Like how can we say, well, I've got 2 different public cloud providers and an on-premise system, I have a similar or same team running all 3 of those, being able to use the same tools and the same monitoring alerts and all those sorts of things becomes increasingly important. Okay, so there are 2 last things you can tell from the gap in the slide, which I'm going to drill into a little bit more detail. First of which I'm going to talk about runtime state replication, and then I will round out with a little bit of discussion on API portability as well. Pause for photos. Okay, so runtime state replication. So this is an interesting kind of aspect of when we're doing that kind of replicated scenario. What are the technical implications that come with that? So just to kind of tell a story, one of the things we see commonly with customers is I've got my often on-premises kind of starting point of my API delivery program, and I then need to think about, well, how am I going to do high availability and disaster recovery of that program? If my main data center goes offline, can I keep running my business effectively? So the way that conversation often tends to go is, well, I have my API running in my on-premises data center. I have a bunch of applications that live out somewhere. Could be internal, could be external on the internet, depending on the particular scenario. And I want to put something like a load balancer in front, so that all those applications get sent over to where I've got my deployment. Seems very straightforward so far, all good. And then the question for this kind of active-passive sort of style of use case is, can I provide a second kind of instance of that API and all the microservices and kind of data backends and so forth that it depends on, running in a logically isolated environment. So the idea here is that's a completely separate instance of your API management platform, not joined together with the first one, so that in the event that the first one goes offline, everything carries on running and can be dealt with independently in that kind of failover location. So we often see customers doing that in something like a public cloud provider. Some other users do it in a second data center or a different region, for example, if you're a kind of globally distributed environment. But there are a number of kind of things you have to think through in terms of how do you make that successful. And in particular, in the kind of this context, I'm focused on what type of data replication did we have to do there. And there are two basic kind of things to be aware of or things to be considering. There's the API definitions. So what is the definition of my API? Which services is it backed by? That tends to be relatively static in nature. So I've got my deployment window. Some customers do a deployment window every month, some do it every week, some do it 10 times a day, depending on what your maturity is in that area. But it's a kind of well-defined period of time. There's a known trigger, sometimes with a change request, for example, that says, go and apply this. And you can use that to drive kind of copying of that same API infrastructure, that same API definition into the second location, into that failover location. Typically, we would recommend kind of using that same CI/CD pipeline to deploy to both instances, and then you know you've got exactly the same thing going on in both places. You can avoid configuration drift, for example. Make sure that you know your failover site is going to do the right thing if you have to call on it. But there's a second type of data which is more dynamic, which is which applications have I got subscribed. So in this case, depending on the type of platform that you have and the type of API you have, that could be relatively static again. So if you have a fixed known number of internal consumers, maybe you have like two departments that consume this particular API, that subscription, that relationship's been set up way ahead of time, kind of personal relationship sort of thing. Again, that static data is kind of easy to put in place. But if you have a public API program, lots of kind of application developers out on the internet consuming your service, that's much more likely to be dynamic. So people could create new subscriptions at any time of the day or night. Actually, in the active-passive case, still relatively easy to handle because you don't need that second location to kind of be ready to run up until the point when the disaster might happen, which is not very regularly. So relatively straightforward in that sort of model. Second one, kind of moving on to a slightly different use case that we see with a customer I was working with in the UK, most recently certainly, is like a burst scenario. So in this case, they have on-premises as their focus area, their kind of first area, but they want to be able to kind of cope with spikes in traffic and send that set of excess requests, as it were, to the second location where they've got the same set of APIs, the same back-end services and so forth delivered. So that might be done, as I've kind of drawn up here in the picture, that might be done with a redirect from one site to another. Sometimes you would use it by kind of diverting traffic at the global load balancer level, just to make sure that you're not overloading that kind of primary location, and you've kind of routed some of the over-the-top traffic to the second bit of capacity where you've got those APIs deployed. Yeah, again, kind of in this case, like the API definition and the subscription data, because it's not changing as frequently as you're doing that kind of failover or that kind of diversion of traffic, relatively easy to handle. So the part where it gets interesting is where I'd like to do an active-active deployment. Best use of resources, kind of making API invocations against both sides. And in this case, again, so the API traffic, still kind of easy to do, CI/CD, change windows, all that kind of good stuff. But the interesting question here is, well, how do I handle the fact that when a new application developer comes in and subscribes, if they're some person on the internet looking to consume my tracking API, for example, how quickly do I want their subscription to get replicated, that data to get sent to both locations, so that they don't end up with a kind of 200 OK response in the primary data center, but a 403 not authorized or a 401 not authorized, whichever one it is, in that second location. So that kind of drives much stronger questions about how do we do that replication? Like, what is the window of replication where we expect that sort of thing to come through? So an interesting challenge to work through in terms of providing two isolated, independent kind of services that provide the same API to the same set of consumers. And then last topic, looking at API portability. So this, as I say, is one that we see from a lot of customers, driven by those same sorts of hybrid cloud scenarios. And for this one, I have an example, again, kind of UK customer that I've been working with in the banking industry. So they have a regulatory requirement, like a financial services regulatory requirement. They're not allowed to get locked into any particular cloud provider. So as it happens, they have built up over time multiple on-premises data centers. They've now got, I think, 2 public cloud providers as well. And the key thing for them is to be able to prove to the UK financial services regulator that they can move their business services, critical kind of tier 1 business services, around and not get pinned to a specific cloud provider. So they, in this case, they're exposing the same logical API from each location, so kind of similar to what we were talking about previously, in order to provide that resilience. So their particular scenario, so they happen to have 2 on-premises data centers and also now 2 different public cloud providers. So providing some isolation, like if one of the public cloud providers has a bad day, chances are the other one probably isn't going to. It doesn't generally happen both at the same time. And to expose their API, currently they've taken a model which says we're going to use different API management solutions in effectively each of those environments. I think they may even have 2 different API providers on-premise as well, but certainly in the public cloud provider, they've picked that kind of native API tooling for each cloud provider. However, in order to then expose the same API, what they've had to do is to basically come up with their own abstract API definition that says, well, what is the thing that I'm trying to achieve? So they have a whole bunch of tooling they've written to say, here's how I'm going to describe at the abstract level what my API is, which backend services it talks to. And then they've also had to write a whole bunch of highly colorful kind of like generation and adapter layer. So they have one leg that says, oh, generate my abstract API definition for my first API provider. Go and generate it for my kind of public cloud provider on the right-hand side, or the second public cloud provider. And that code is expensive. It takes a long time to build. It's something they have to maintain and manage on an ongoing basis, so that they know when they say, I want to deploy my payroll API, that will get generated and successfully run in all 4 of those different API platforms running in the different environments. And the other angle this happens to then drive is it kind of forces a lowest common denominator model across all of those cloud providers, because your abstract definition is something you then have to be able to generate into an implementation for each of those different environments. So it's expensive to maintain and run, and kind of hampers their innovation, because they're not able to take advantage of the exciting and the more advanced API features that may exist in any of those individual providers. So an alternative model is actually something that we recommend from an IBM perspective, as you probably wouldn't be too surprised to hear me say, is that we have our API, IBM API Connect solution is a hybrid cloud platform that you can deploy and run anywhere. So whether it's on-premise, different public cloud providers, I'll talk a bit about more about the form factors in a minute, but it effectively allows you to use that same API platform in whichever environment you happen to be running in. So given you can then put that same provider in all 4 locations here, you can then stick with a concrete API definition for that provider. Obviously much less for the bank in this case to have to own and maintain, because they're kind of only dealing with the one implementation, and also conversely means they can pick up all the kind of provider specific powerful features that exist and use them consistently and reliably across the entire deployment of their estate. So that's a very different approach to achieving API portability, kind of mix and matching the first scenario, which is the customer, the bank in this case, had to run their own portability layer and maintain and manage that, but versus this approach that says, well, I can get the same API provider in all those different locations and treat it exactly the same, because it's a consistent deployed offering wherever it happens to run. So as I hinted, just to kind of close out, obviously from IBM, we have that hybrid cloud API management platform. It's called IBM API Connect. You can see in the middle here. So it runs, you can run it as a self-installed and a self-administered offering in VMware, in Kubernetes, in OpenShift. It also exists as part of our Cloud Pak for integration, which includes all the other integration offerings that I was describing at the beginning when I was introducing my role. So not just API management, but also app integration, Kafka events, enterprise messaging, all those other sorts of things alongside our API Connect solution. So both of those are kind of custom managed, self-installed, your own administrators, your own operations team running them in whichever environment you'd like. And then we also, on the right-hand side, provide managed SaaS options as well. So you may have seen on our booth, there's a kind of self-service sign-up for our AWS trial. You can come along, we run the platform for you in AWS and also in IBM Cloud, potentially other clouds coming in future, obviously. And that provides IBM doing the hard work of the administration and the install and management and so forth, and gives you that flexibility to focus just on the APIs. But the important thing is, whichever of those form factors you pick, it's the same API deployment. It's the same YAML file, effectively, that you deploy to each of those environments, whether they're running on-premise or in different public cloud providers or hosting vendors. So just in summary, so hybrid cloud API management, we're seeing that from an IBM perspective a lot, increasingly common as enterprises and businesses kind of mature in their adoption of APIs and the strength of that delivery. Wide range of different patterns and use cases. There's a wide range of different patterns and use cases, as I was just describing in the various pictures. Technical aspects to be considered when you're kind of thinking about those sorts of deployment scenarios. and certainly the API portability is one of those critical factors that companies have to think carefully about in order to be successful and be agile and kind of drive success in delivery of a hybrid cloud API management platform. With which, I thank you for your attention.
Awesome. Thanks so much, Matt. Any questions? Yeah. Wait, hold on.
Yeah, and just have a question. In the load balancing part, when we've got API in different hybrid environments, it's difficult for the load balancer to know exactly if the environment is up, because the API could respond anytime, but as soon as we want to do effectively something, well, one of those crash and all the other works okay.
Yep. Yeah, so I think there's kind of two approaches there. There's a synthetic health check, which is an approximation of whether your API is kind of up and running, which is easy to implement, but not as accurate. There are some cases, so you could use analytics output of the actual invocations of the API to understand whether 200 OK is being returned regularly, or if you see a spike in 400s, for example, and use that to drive the workload routing behavior at the load balancer level.
Matt, in your experience dealing with customers, have you seen much of the demand for managed gateways? As opposed, I take it that customers want managed API management control plane, but if you say there are demands for managed gateways, what percentage of customers, especially enterprise customers, asking for managed gateways as opposed to as their own managed gateways, either in cloud or in on-prem?
Yeah, I'd say so. What we are seeing is a lot of customers kind of either beginning or kind of reasonably far down that kind of journey of public cloud adoption. The typical pattern we get asked for is, can you manage the whole thing for me in public cloud 1, public cloud 2, whichever one that may be. The cases where we see the kind of remote customer managed gateway tends to be perhaps geographically distributed scenarios, or the customer has their own lots of data centers, kind of spokes on the outside of their network. And in that case, the question then becomes, can I manage the control plane centrally and yet still push that out and have the actual invocation run in, I know, the manufacturing location or the car dealership or whatever it happens to be.
Great. All right. I think we're at time. Thanks so much.
Thanks, everybody.